Take three. All right, hello folks. As you guys know, I do a lot of tutorial videos, especially when I learn something new and I get excited about it, like, advanced BGP or Mangle or any of that exciting stuff. And I also do teardowns on equipment when I'm tired, unmotivated, and lazy. But something which I started getting into is learning AutoCAD. And that's because with 3D printing, which 3D printing for me means I can make tools, devices, repairs, any kind of little bits and pieces that I need for everyday life or projects that I'm working on because I like making stuff, right? So it's becoming a invaluable tool. So now what I'm working on here, actually, I just wanted to give you guys a preview, is I've been working on a standby power system, a modular system that meets NEC compliance, and it's just a drop-in that you can stick at the side of your house. So what I'm working on here is, actually I'm kind of proud of myself, is the charging system right here. So this is 150 amps of charging module using standard RV power converters. They're not cheap, but they're multi-stage chargers that maintain the batteries and keep everything happy and healthy. And FYI, I did cobble these together myself, so if you guys are impressed, great. If you guys are like, then please reach out and teach me how to use AutoCAD better, because I'm really struggling. So we've got our shelf here. I'm going to design it into a 2 or 3U shelf, depending on how the power converter modules fit. In here is a bracket which I'm designing for my Renogy power inverter, as I have a Renogy 3 kilowatt pure sine wave inverter charger, which I use to run my office, my fridge, my furnace, the lights in the house, the internet, all that sort of stuff, right? So the concept here, the one I'm actually designing, is rack mountable bracketing. This is where this started, by the way, is that this bracket here, I'm designing it so that I can fit my Renogy inverter into it and then slip it into the rack, my outdoor rack that I have, and which I kindly got or received from Golden Rural High Speed. They provided me with a nice outdoor rack that they weren't using. Yeah, so this will go into the top of the rack, and then below it will go the breakers, which I don't have the breaker drawing yet. I need to get the model from my friend, and then I can start working on that. And then this is something which I'm working, which is more recent. This is actually the modules, the charge modules, to give me a boost, because this guy here is only capable of charging at 75 amps. Now my battery bank, my storage capacity currently is 1400 amp hour at 12 volts, which usually carries me in the, well, this spring while we were without power, I went a solid 20 hours before I felt the need to put on my generator. But 75 amp is not a lot to charge that. Let me get my calculator and I'll explain why. So if we've got 1400 amp hour divided by, sorry about the noise, I am in a factory, 12 volts, we get about 116 amps, okay? So now, if you take 116 amps and multiply that by, let's see here. Oh, no, that's 100, yeah, 116 amps. Hold on, let me do the math one more time. You can see where I was going with this, and I had a brain fart with the noise. So the battery bank is 1400 amp hour, okay? So if I want to replenish that, let's see here, divided by 75. There we go. That's the math I'm looking for. It'll take me 18 hours to charge it at 75 amps. So with the charging capability of this inverter, it'll take 18 hours to charge that. And now, in addition to that, so let's see, 12 times 75. That's only 900 watts I'm pulling from the generator. My big generator is capable of 12 kilowatts. My small generator is capable of 3,000 watts, 3 kilowatts. And the battery bank itself can be charged at 25% of its capacity. So if we say that we're running at about 1400 amp hour, and then I think that the math is times 1.25 minus 1400. So I can charge at 350 amps safely without damaging my batteries. So what I'm doing is since this guy here is 75 amps, And these two here are each 75. So that's an additional 150. That'll take me up to 75, 75, 150 plus 75. What is that? 225. So let's see here. So 75 times 3. All right, so 225, yeah. So at 225 amp hours, now let's see how much that current that can draw. 12 times 225 equals 2,700 watts. That's almost at the capacity of my little Champion gas generator, which is awesome because I'll be making full utilization of it now. So now let's see how long it takes to charge 1,400 divided by 225. So now I can replenish my battery bank in 6 hours using these 3 chargers. And this is kind of what I'm going for right now at this stage of the design. So with the large gen set that I have, which is capable of about 12 kilowatts, it is split phase, so it's 120/240, which means that you want to equally load the stator, otherwise you can cause issues with it, right? You can hurt the generator if you don't load it properly, right? But I'm actually at the threshold right here at 2,700 watts, where I'm not going to hurt the generator by only using one phase of it for 2,700 watts. And additionally, I haven't found the true answer yet, but I've been told that I can rewire my Generac as a single phase 120 volt 100 amp generator instead of 240 volt 50 amp. So now back to the project at hand. So using these 3 charging modules, these 2 here on this shelf, and this guy here, I am now capable of charging my batteries within about 6 hours. So that means that my generator doesn't have to run all day and all night. So essentially, every time my batteries hit about 11.3 volts, here, let's pull this up, by the way, another little thing. 12 volt battery swing range, I think is what it's called. Let's see here. There we go. This is the charge I want. So if you can read that, and by the way, this is great for attribution because you can see where I'm getting the information. So when you're looking at these AGM batteries, we typically don't go over 13.4, but we can charge them at 14 volts quite safely, and that also helps with a little bit of desulfation. Now, once you get your battery down to about, see, 11.7, it's at 25%. I got down to 11.3 before I started my generator. So the idea is that I'm going to have an external generator that will automatically kick in at about 11.7 volts. And so once I get down to 11.7, generator kicks in, these guys start pumping power into my batteries, right? All 3 of these guys together, and that will bring the batteries back up. Or alternatively, because this inverter itself, you can program it with different parameters, or operands, I think is the appropriate term. What I can actually do with this guy is I can set it so that if the batteries get as low as 11.7 or 11.5, or if the load itself becomes greater than 30%, 40% of what the inverter is capable of, it'll activate the generator for me, which will then bypass this. This will go into bypass to run the household load directly off of the gen set while charging the batteries at the same time. So with that kind of intelligence, it really ties all this together. Also, the generator is only going to come on when it's really needed, which means you're not going to be wasting fuel by having it sitting there idling. Plus, it'll be a lot quieter because the generator is not running all the time. So, as you can see, in AutoCAD here, I am building all the modules with explanations and whatnot because I am outsourcing some of the equipment. Like I'm getting this built at Peterborough City Welders, I believe. They're making this bracket for me. So I'm going to be submitting this to them next week when I get home from Brazil, and they're going to help me optimize this design and then make the bracket for me. This guy here, I literally just bought a rack off of Amazon, like a 2U. And when I get home, I'm going to start mounting all this equipment into it. This will also tell me for sure if these are bigger than the 2U. If they are, I might go to a 3U only for the sake of having the charge modules lower than the actual rack so that, it's tidy. I don't know. It really doesn't matter at all. But in the end, my end game here is to be able to have the cabinet with the modules and everything in it so that I can do CAD demonstrations with it for investors who are interested in building my product. and yeah, be able to like basically do what's called an exploded view, which is where, in my case, this would all slide out of the rack. These power modules would slide out of the rack, you know, all that sort of stuff. So that's kind of where we're going with this. So there you go. We shall now be able to visualize things and build things a lot easier thanks to CAD. Now, the next big thing in my journey of education is I'm going to have to learn how to use a proper CAD suite like FreeCAD or something because I don't know. What do you guys suggest for CAD? What's a good free CAD software? Because I've tried Autodesk, but for some reason, it won't let me use the free version. It keeps saying that I have to pay for it, and I can't get over that. I think Onshape or OpenShape is free as well, but I think FreeCAD might be my best choice. But in the meantime, if you guys have any suggestions about which CAD software I should be using, that's also easily, they're similar to Tinkercad because I've been learning this, or want to teach me a little bit about AutoCAD, I would love that so much because this is just, it's really nice to be able to like, you know, build this stuff, you know, and put it all together in the way that it's supposed to be and visualize it. It really helps when you're trying to figure out how everything fits together, you know? So there's a boring video guide for you guys today, but you know, I figured that not all of my content's going to be exciting for everybody, and this might be an opportunity for me to reach out to more makers out there, you know, reach more makers that are interested in seeing the sort of stuff that I'm developing and working on. So there we go. There's a bunch of stuff which I've made over the last couple of days in rainy Brazil. All right, we'll catch you later, guys. Ciao.